All right, here goes solving radicals part 1. Still part of Unit 6, square root functions, and we're still in the radicals. So today we're going to solve for a variable in a radical equation. So we're going to go ahead and, this is our lesson on solving radicals, and then you do have some practice problems on homework to work on. Okay, so here's our notes. This is not part of your Google Slides, so if you'd like to go ahead and add that, you can. Otherwise, I'd really appreciate if you guys are using your paper notebook, because really doing math with a pencil and paper, there's just something about it. So please go ahead and have your paper notebook and follow along and make sure you're writing things down. If you don't understand something, please seek the help you need. I hope there's somebody with you that you can ask questions. Otherwise, please go to tutoring and ask Miss Young or anyone else on the tutoring list. All right, so radical equations is an equation in which a variable appears under a radical side. Simply put, we practice these a little bit at the beginning of the year, and we are going to have to, once we solve it, we're going to have to double check that our answer is correct. Okay, because remember, we do have that positive and negative square root. And if we have both of them, that would end up being not a function, and it would be an extraneous solution. So we're going to talk about that in this lesson today. All right, so we're going to isolate the square root and then square the square roots. That's what we're working on. Okay, so for number 1, the absolute value is already isolated. Okay, so we can go ahead and take care of that by solving for x. Just think about what is the inverse in order to get rid of a square root. That's to square both sides. Now, the square root of 2x plus 5 squared, that would simplify. And the cool thing about that is I'm going to show you real quick. 2x plus 5, if we were to rewrite that in radical form, okay, that's really 1/2. Now, if we square 1/2 and we multiply 1/2 times 2, that just becomes 2 divided by 2, which would simplify out, and that would just become 1, and the radical's gone. So that's an exponential form. So that's why when we square a square root, they simplify, and that just becomes 2x plus 5. And then we're left with 7 squared, which is 49. This is basic math. You know what to do from here. Subtract from 5. That's going to give us 45 equals 2x. And x just equals 22. Now the difference with this now is that we do need to double check our work. Okay, so check it. Okay, by checking it, we're substituting it back into the original equation. So the square root of 2 times 22 plus 5, okay, does that give us 7? Let's simplify. 2 times 22 gives us 44. 44 plus 5 is going to give us the square root of 49. One of our solutions for the square root of 49 does equal positive 7. Okay, so that does work. 7 equals 7, and we are good to go. All right, let's take a look at number 2. Number 2, I'm going to jump over to red. And we're going to go ahead and first start by, we need to get everything away from that radical before we square both sides, because it's not pretty if we start off right here squaring this. Because we have to square a binomial, and then there's radicals. Don't do that. So we need to go ahead and make sure everything's removed away from this radical before we can do anything else. So I'm going to add 4. That would become 12. You can see that we need to go ahead and divide both sides by 2. And we're left with the square root of x equals 6. Now that's a little easier to look at. We can square both of those sides to get rid of the radical, so the square root squared is gone. We're left with x equals 36. We're not done though. We do need to double check our answer. So we're going to check that. And so I'm substituting 36 back in. 2 times the square root of 36 minus 4 equals 8. Square root of 36 is just 6. 2 times 6 gives us 12 minus 4 equals 8. Yay! So that means that x equals 36 is a solution for this equation. All right, let's go ahead and take a look at number 3 and number 4. For number 3, there's a lot going on. But remember, we just need to get everything away from that radical before anything else. So this radical is important to get everything away from. I'm not going to start with that fraction just yet. We are going to subtract both sides by 7. And we're left with -4 on the other side. Next step is we're going to go ahead and multiply by 2. Alright, now I have some warning signs going off in my head. A positive radical equaling a negative number, I don't think that's supposed to happen. Okay, if you can notice right there that this is going to not work, then you can just go ahead and say no solution. Because ultimately, the value of x is going to be an extraneous solution. Okay, but let's say you didn't see that. And the next step is to go ahead and square both sides. And you squared it, and it's x plus 2 equals, this would become positive. We lose that negative. Positive 64. And we're going to subtract by 2. And x just equals 62. Yay, we're done. We found x. But wait, if you don't check your work, you're going to think you've got the right answer. But you don't. So you would have like -2 points on your quiz. So please make sure that you do check your work. So let's go ahead and substitute it back in. So we have 1/2 square root 62 plus 2 plus 7 on the outside of that radical. I'm plugging it right back into our original equation. Simplifying life here, 62 plus 2 is going to give us the square root of 64. Square root of 64 is 8 times 1/2 plus 7 equals 3. Half of 8 is just going to give us 4 plus 7 equals 3. Hey, I can tell right now this isn't going to work. Okay, so when we end up with 11 equals 3, no way, that's not going to work. Okay, so in this case it's going to be no solution. Okay, so let's go ahead and take a look at number 4. So looking at number 4, I'm going to change the color pen. Here we go. With number 4, we're going to go ahead and we need to isolate the radical. And the way that we're going to do that is this plus 2 needs to go to the other side. So we're going to go ahead and subtract 2 to both sides. Now we're left with the third root of x minus 3 equals 1. Okay, so I have the cube root instead of a square root this time. So if I am looking at this, I really want, if I write it in exponential form, you'll see that it's going to be 1/3. To get rid of a 1/3, we need to multiply it by a 3. If we have a cube root, the only way to get rid of that is to cube it. So we're going to go ahead and cube both sides of the equation. That would simplify out. I'm left with x minus 3 equals 1, because 1 times 1 times 1 is itself. And the only thing you have to do left is add 3. X equals 4. In class, I would be like, hey, I'm done, right? Yep, cool. No, you need to double check. So check your work always. Okay, now, with this, we're going to go ahead and put 4 in the cube root, which is going to end up giving us 4 minus 3 cube root plus 2, that's driving me nuts a little bit, equals 3. So we're going to go ahead and simplify life. So 4 minus 3 is just going to give us the cube root of 1 plus 2. 1 plus 2 gives us 3. 3 equals 3. Okay, I'm going to tell you something about cube roots though, because remember how cube roots look like this? And this one actually has parameter shifts of up to, and it's going to go right 3. Oh wait, we've got that 3 on the other side. We can't do that. We have to actually subtract it over. So when we subtract that, that would actually go down 1. Sorry, trying to go on the fly. So we're going to go down 1 if we subtract 3. So this graph is going to end up looking a lot like down 1 and then right 3. 1, 2, 3. And it is positive. It's going to look a lot like this. we do not have any domain or range restrictions on this. So actually, the value that you receive algebraically is going to work. But you know what? If you forget that, always double check your answer. Okay. It'll also allow you to see if your value was algebraically solid. If you made a small mistake, it'll catch it. Alright, so let's take a look at number 7. So with number 7, I noticed something interesting about this one. I noticed we have radicals on both sides, and I can't isolate the radical because if I just divide both sides by 8, that doesn't really do anything for me. This now becomes just a fraction with 8 divided by it, and it makes it look harder than it really is. So, whenever you have a coefficient in front of a radical, it's okay. You can leave it there. Just remember, you're going to have to square it, or cube it, whatever you need to do, depending upon the index of your radical. Alright, so if this is squared, we're going to end up with 8 times 8. 8 times 8 is 64. Okay, now, I'm squaring this. So, if this is being squared, what we're going to end up doing is we're going to have to, well, the radical would go away. Sorry. Overthinking things here. This would just be x plus 14. Okay. Our radicals are completely gone. Please make sure when you have something coming outside of a radical, you put it in parentheses because you do need to distribute both of those terms by 64. So this is now going to become 64 minus, calculator, whoa, that's 128, but I'm going to double check. Yeah, equals x plus 14. Now we solve it like we would normally, and we're going to go ahead and we're going to move over x, it's the smaller coefficient, and add 128. This cancels out, this also cancels out, we're left with 63x equals 142, divide that by 63. Okay, I was just triple checking there. Our end answer is 142 divided by 63. There are no factors that will go into 142 or 63, so that's going to be our end answer. We're going to go ahead and plug that back in to see if that is going to work. Okay, and I'm just going to go ahead and substitute that in. This isn't going to be pretty, but it's 142 divided by 63 minus 2 equals the square root of 142 divided by 63 plus 14. Alright, ready for the non-pretty part? It's not going to be too bad though. So, in order to add fractions, remember we need a common denominator. So, the common denominator here would be 63. This isn't 63 over here, so in order to subtract that, we're going to have to multiply the numerator by 63 and the denominator by 63, so that would just be 8. Okay, 2 times 63 is going to give us 128. Or, not 128, sorry. I was looking up ahead. Okay, 63 times 2 is going to give us 126. So we're going to have 142 minus 126. I'm going to give myself a little bit more space, so we have 142 divided by 63. Sorry, 142 minus 126 gives us 16 63rds times 8. Let's go to the other side and see what we end up with. And what you could do on this one is just see the decimal answer and substitute that into both sides. I'm going to tell you right now, because this problem is getting kind of ridiculous, that this is a solution and both sides are going to equal. When this problem was originally formed, this 2 wasn't there. Okay, well, I feel like I need to go over it, sorry. Let's keep going. So over here, if we're creating a common denominator, it'd be 63. So then you're going to have 142 63rds plus 14 times 63, which is going to give us 882 divided by 63. Now, 142 plus 802 is 1024 over 63. Okay, now at this point, this is where I was telling you can probably go ahead and find what the radical would be, or if you want to look to see, okay, this 8, we're going to be looking for 64/16 of 63 inside this, so you can actually divide that out and see how many times 63 does go into it, and it's 16. But what we really need to do is just multiply it. So 8 times the square root of 16 63rds is going to give us 4.03, and the square root of 1024 divided by 63 is going to give us 4.03 as well. Those are congruent, so both of those equations work. This is our crazy value for this problem. Alright, let's go ahead and take a look at our last problem, number 8. So looking at number 8, we're going to go ahead and subtract 3 from both sides. So we're left with x minus 1 equals x minus 3. Okay, because we need to isolate the absolute value, that's our first step. Now, I notice there's x's on both sides, but that's okay, because we're really trying to focus on getting rid of the radical first. So this radical, we're going to go ahead and square it to get rid of the radical. If we square both sides, this would end up being x minus 1 is a square, and the square root go away. X minus 3 squared, so remember that's just going to be x minus 3 times x minus 3. If you always fail when it comes to squaring a binomial, please go ahead and write it out. Alright, x times x gives us x squared minus 3x, okay, plus 9. Okay, simplify the inside, that's going to be x squared minus 6x plus 9. Wait a minute, we need to solve for x. So remember, when we're solving, we actually need to factor this one, and we need to pull everything over to the other side and set it equal to 0. Okay, so we're going to subtract x from 6x, negative 6x, and we're going to, I don't know why I wrote 0, because in my mind I was like, this must be 0, and then we're going to add 1 over to the other side. So this is going to become 0, which is exactly what we're looking for. Okay, and we want x squared minus 7x plus 10. So if we're factoring, remember we need the factors of 10 that add up to give you negative 7. Okay, so those are, let's try 2 and 5. Hey, that's going to work if I make them both negative. And if I make them both negative, they're going to multiply to give us that positive 10. So that works. We're going to go ahead and minus 2x minus 5x plus 10. And remember, we're going to go ahead and factor by grouping. So go ahead and bring down your the middle, split the middle. After we split the middle, what can we factor from the first two? Just x, and if we factor x out, we're left with x minus 2. On this side, I noticed that I have a negative at the beginning, and I had a negative in the middle for over here, so I need to factor out a negative number. Both of them have negative 5 in common, so we can go ahead and factor that out. Negative 5x divided by 5 is just going to leave us with x. 10 divided by negative 5 is going to give us negative 2. I notice I have negative 2 on both sides, so I'm going to go ahead and factor that out and bring that out in front. So x plus 2, or x minus 2, and x minus 5. Whew, we're not done yet. We still have to, those are just factors. X is going to be 2 and 5. Now, with irrational functions, you may have one as a real solution and one as an imaginary solution or an extraneous solution. Okay, so we do have to double check both of these. I'm going to change my color here to blue, and we're going to double check 2, and we need to double check x equals 5. So when we look at the x equals 2, we're just substituting it in. So we end up with 2 minus 1 plus 3 equals 2. Okay, so wherever you see x, you're going to substitute it right back into your original equation. So that just becomes 2 minus 1, which is the square root of 1, plus 3 equals 2. I can already tell you right now, this does not look good. It's 4 equals 2. That's not going to work. This one is no solution. Let's take a look at 5. So we substitute that back in. 5 minus 1 plus 3 equals 5. Okay, 5 minus 1 is going to give us the square root of 4. Plus 3 equals 5. Square root of 4 is just going to give us 2. Check it out. We've got 5 equals 5. Woohoo! So that means that x equals 5 is our only solution for this equation. Okay. Just like any time or any lesson, what I'd like you to do is if you have any questions that you don't understand, please make sure. Did we not go over 5 and 6? Oh no, I'm not crazy teacher. I apologize, I looked back at my video and I totally skipped 5 and 6. There you go, you get your authentic teacher back, just for a moment. And if you were freaking out because I skipped 5 and 6 like 10 minutes ago or however long that was, I'm sorry. So, looking at this, we can go ahead and take a look at number 5 and number 6, and really if you understood how to do the 7 and 8 you should be good. So go ahead and pause the video and try to do 5 and 6 on your own because the steps are very similar. So yeah, go ahead and do that. I'm going to pause, set it up, and then kind of talk through it. Alright, so looking at this problem, the first step, the radicals are on both sides, but they're also both isolated. So the first step is to go ahead and square both sides. Once you did that, you ended up with 8x minus 14 and 6x plus 10. Okay, just like everything normal, you're going to go ahead and get the x's on one side, the variables on the other. You should have solved it out, got x equals 12, plugged it back in, simplified it all the way down to the square root of 82. You don't need to simplify it any further. If they equal when you get to a point where they equal on both sides, cool, awesome. This is a solution and we can go ahead and move on. Okay, let's go ahead and take a look at number 6. Same thing, go ahead and stop the video, work it out, see if you end up with the same. Alright, so you should have squared both sides first. Remember 3 squared is 9. Square root of x is just going to give us x, and then we're going to go ahead and solve it like we would normally. X equals 2. I stopped at this check just to show you something. If you end up with the square root of 18 equals 3 times the square root of 2, don't just stop there, but actually factor that 18 out. Because remember, 18 is just 3 times 6, and then 2 times 3. There's a group of 2 3's that you can pull out, and then the 2 stays on the inside. So the 3 represents that group. 2 square root of 2 equals 3 times the square root of 2, and you're good. You're golden. Okay, so 2 is a solution. Sorry for mixing up this video, and I'm going to see if I can fix it in the end. But if I can't, I'm just going to leave you guys comments about it. Have a wonderful day. If you have any questions about how to do these things, please log on to Tutoring with Miss Young or some other math teacher that is offering tutoring, because there will be people helping out. Don't be afraid. Seriously, if you don't understand something, don't wait till the end of the quarter. It'll just only be harder for you. All right? So, have a wonderful day, and I hope all your classes are going well. Bye.